Alright, so this video will be relatively short. We only had one page left to do in lesson 3. We actually have completed most of the problems beginning at 12. We were actually on problem 15 in the class, but I thought I would start with actually problem number 13 because 13, 14, and 15 all go together. So problem 13 is asking you to give a trig rule that will help us find the x value. So we're talking about in finding the x value, we use cosine of theta. And for the y value, we use sine of theta. And this idea will come back in the next lesson. So keep in mind that we use cosine theta because in our unit circle, I'm looking for the x value or the y value. When we put in our right triangle here, our x value and our y value, theta, that cosine of theta is x over 1, adjacent over a hypotenuse, which gives me x, and sine of theta is y over 1, again it simplifies to y, and again, that's when we use a unit circle. So for a unit circle, we talked about, well, I was trying to get these values here on the graph, and what we talked about is the fact that if I change everything into sixths, that this pi over 6 is actually exactly between 0 and pi over 3. Pi over 2 is exactly between pi over 3 and 2 pi over 3, and again, and so on. So all these values are exactly between the other values. And then based on the table that I showed you, and that would be all 4 quadrants, I asked you to copy down the numbers you might need. And so all of these numbers were in the table, and again, based on the quadrant you were given, you had a set of them to begin with. But in class I posted all 4 tables so that you could copy down the information that you needed. So, at 0 radians, the answer is 1. At pi over 6, the answer was like 0.8687. I talk about that this is cutting off by 2/10, so right here. Pi over 3 is 5/10 in here. And then pi over 2, the answer is exactly 0. At 2 pi over 3, the answer is negative 5/10. At 5 pi over 6, we're at negative 0.87. And then at pi, we're at negative 1. At 7 pi over 6, the answer is negative 0.86 or 87. 4 pi over 3, we're at negative 0.5. 3 pi over 2, we're at 0. 5 pi over 3, we're at 0.5. 11 pi over 6, we're at 0.87. And at 2 pi, we are at back up to 1 again. So the graph is not linear. Actually, it's curved. So this is what the graph looks like. What is the name that we give to this graph? Since all of these values are for the x-coordinate, I'm hoping that you thought about our answer to problem 13. X-coordinate is a cosine problem. This is the cosine graph. And how would you draw the graph from 2 pi to 4 pi? And so the question becomes, first question is this graph periodic? In other words, should I expect, based on the circle, if I go 360 degrees, or 2 pi, should I expect that I am going to repeat my answers? In other words, 0 pi and 2 pi, where both answers are 1. When I come back around to 4 pi, I'll be right back to where I was at. If I'm up here at the top, for example, which is pi over 2, but if I go around again, that would be 5 pi over 2. I go around again, and that would be another 2 pi. So I keep going around, and it'd be an additional 2 pi each time. So the function itself, hopefully you understand, is periodic. So the graph from 2 pi to 4 pi is the same as it is from 0 to 2 pi. So if I took a sheet of patty paper and traced this graph and just slid it to the right so that this point here matched up with this point here to begin the graph again, that's what the graph would look like. And it would continue to look that way every 2 pi. So the period of our cosine graph is 2 pi. And it repeats every 2 pi. So going back to the periodic function, the function back in lesson 1 looked like this, which says that basically that I expect that every time I add on 2 pi, I'm going to get back to the same answer as the original answer. So, for example, at 0 pi, if I add 2 pi, they're both 1. If I add 2 more pi, it's 4 pi, I'm back to 1. If I look at pi, let's do pi. Pi is at -1, so if I add 2 pi, which is 3 pi, I went back to -1. If I add 2 more pi, which is 5 pi, I went back to also -1. So every time I get to, I keep adding another 2 pi, I get back to the same answers as I did in the original answers from 0 to 2 pi. So the function itself is periodic. So continue in the outline in Canvas. You will find 2 more videos for the next handout, and then two worksheets for homework, one for lesson 3 and one for lesson 4. Come with those completed next Wednesday. I'll take any questions we have, and then based on our conversation on Wednesday, I will either collect them Wednesday or provide you some time to correct your mistakes and collect them on Friday. But a lot of it will just depend on the types of questions you come back with on Wednesday.